Professor Hatherill, thank you for taking time out to speak to us today on the commemoration of World TB Day. Could you possibly set the landscape for us and just tell us why, particularly in Africa, we need to observe the World TB Day?
Thanks, Alana. Yeah, it's a pleasure to talk to tuberculosis and the prevention of tuberculosis for World TB Day. And I think the important thing is that tuberculosis is not a uniquely South African problem. We are global citizens, and every year more than 10 million people develop tuberculosis, and just over 1.5 million people die of tuberculosis worldwide. And for the first year for which we have data available in the last decade, which is for 2021, TB incidence rose for the first time. So our TB control efforts are not working compared to pre-COVID. So as global citizens, we should be concerned that tuberculosis control is a major issue. But of course, in South Africa, we are particularly affected. We have approximately 300,000 cases of tuberculosis each year in South Africa. So 300,000 individuals affected by TB, 300,000 families affected by TB. And that translates into an incidence per population of more than 500 per 100,000, which is astronomical on the global scale. So we have a particularly high TB incidence as well as a high TB burden, and it won't be lost on anyone that this high TB burden in South Africa, or high TB incidence rather, in South Africa and in sub-Saharan Africa also overlaps with countries where we have an existing TB vaccine. So we need a new TB vaccine to help control tuberculosis.
Well, thank you for that. Can you maybe just tell us a bit on what highlights there has been for scientists on the development of TB, and maybe just what SATVI's contribution has been to the development of these new vaccines?
Sure. So I want to highlight two successes, because there have been some successes in tuberculosis vaccine development. So in 2017, we published the results of a trial of BCG revaccination of adolescents, which showed 45% efficacy in preventing IGRA-negative adolescents from converting their IGRA to sustained positive, which is we think analogous to a state of sustained infection. So there's promise that a strategy of using the existing vaccine that we have, which is BCG, and using that vaccine to revaccinate adolescents might prevent TB infection and possibly subsequent disease. So that's the one success. The second success, which is even more promising, is a trial that was conducted by not only by SATVI, but by other groups in the University of Cape Town and elsewhere in South Africa, and in fact in Zambia and Kenya as well, is a trial of the novel TB vaccine candidate M72 ASL1E. And those results, published in the New England Journal of Medicine in 2018, showed that vaccination with 2 doses of M72 provided to IGRA-positive people. So in other words, people who've already been sensitized to tuberculosis and potentially infected with tuberculosis, that vaccination of that population provided almost 50% vaccine efficacy against progression to TB disease. So this was a key result. It was the first time that it had been definitively shown that IGRA-positive people, that TB-sensitized people, could be protected against progression to TB disease by vaccination, and the first efficacy signal for a protein subunit TB vaccine. So tremendously exciting.
That is very exciting, Mark. And the news of the protection efficacy that is coming into play is very exciting, especially for latently infected individuals. Could you tell us, it is well documented that when available, safe and effective TB vaccines will be a critical tool to the global efforts in ending the TB epidemic. Can you share your insights on how close the world is to developing a safe and effective TB vaccine?
That's a question I wish I knew the answer to. But I can give you a sense of what is coming in terms of trial results, efficacy trial results, as well as new efficacy trials that have started. But I think I want to emphasize that in terms of achieving a success, this is not going to be a quick fix, because tuberculosis is a slow-growing organism. Cases of tuberculosis accrue very, very slowly in trials, and without an immune correlate of protection that tells us in the blood or another sample set who is protected and who is not after vaccination, then we have to wait for these large and long efficacy trials to happen. So in terms of results that are imminent in 2023, so there are two efficacy trials that are completing. The first, or that will deliver results. The first is an expanded trial of BCG revaccination, which was started to confirm the results in negative adolescents, this time with a larger sample size in more sites and with a slightly wider age range. And that trial will report a primary analysis, we think, sometime in 2023. So that'll be exciting for, and it'll stimulate discussion of the importance or the place of prevention of TB infection in preventing subsequent disease, whilst recognizing that maybe we need another trial, another very large trial to demonstrate that as fact. But I think it'll be certainly if there's another positive efficacy signal from a larger trial, then there'll be a lot of focus on the potential role of BCG revaccination for adolescents in countries like South Africa. So those results from the primary analysis we would expect sometime this year. And the second trial that should be reporting results in 2023 is an efficacy trial of the protein subunit vaccine H56, which has been tested in a prevention of recurrence trial. In other words, it's been tested when given to TB patients who have been successfully treated and cured, given to TB patients at the end of that treatment course in order to prevent recurrence after the end of treatment. So that trial should report in 2023, and those results will be eagerly awaited, not only because that vaccine might have a role in addition to the TB drugs we provide to TB patients, but also if this trial shows an efficacy signal against recurrence of TB, whether that is reinfection or recurrence or true relapse, then that might greenlight a large-scale prevention of disease efficacy trial of this H56 candidate vaccine. So both of those results will be eagerly awaited. In terms of other trials that might deliver, and here we're talking about the silver bullet. There are two trials that are starting or have only just started. The one is an infant trial of the live attenuated Mycobacterium tuberculosis vaccine, MTB-VAC, and that is a large multi-center trial being conducted in several thousands of infants in sites in South Africa, Senegal, and Madagascar. and that trial has only just started, and results will only be available likely in 5 to 7 years, so by about 2030. And similarly, for the candidate vaccine M72 AS01E that I mentioned earlier, despite that very exciting efficacy signal of 50% protection against disease in IGRA-positive people, it has taken 5 years since those results were published to plan and operationalize a large phase 3 trial to confirm those findings. And that trial will start again with a much larger sample size, more than 20,000 participants to be enrolled in multiple sites in multiple countries. But again, those results should be available only by 2030 or so. And there are 1 or 2 other products that are planning efficacy trials, but you'll get a sense that for these large-scale endeavors, it takes 5 years or longer to conduct an efficacy trial that will give us an answer. So I hope I've answered the question in terms of how likely are we to get a new and effective TB vaccine. I think it is likely. We have promising efficacy signals and promising candidates. When will that happen? That I can't tell you, but I can tell you it's not going to be a quick fix.
Thank you, Professor Hatherill. Just to the general public or healthcare worker community, could you explain the term IGRA-positive people in the context of TB?
Okay, so IGRA, or interferon gamma release assay, is a test that we use to tell us if someone has been sensitized against tuberculosis. Which is similar to how we use the tuberculin skin test. Both IGRA and TST we have tended to talk about as telling us about latent tuberculosis infection, but that's probably a misnomer, because we don't truly know, amongst the many people who are sensitized against tuberculosis, we don't truly know which of those people are infected and which of those people are not. But it does seem to make a difference whether when someone is vaccinated with BCG or one of the new tuberculosis vaccines, it does seem to make a difference in certainly in immunogenicity and maybe in efficacy, whether that person has been sensitized to TB before. So that's why it's important that these vaccines are tested in IGRA positive and IGRA negative people, as well as in diverse communities and countries, and in people with and without HIV, for example.
Thank you for that explanation. Professor Hatherill, you mentioned 2 novel TB vaccine candidates that are currently being tested, the M72 and the H56. Could you possibly just explain to us how these are different from the BCG vaccine? And having made so many strides with those novel vaccines, do you still envisage that BCG will still be around after development of more modern vaccines?
That's another hard question. Okay, so firstly, BCG has been around for more than 100 years, and it's still around because it works. So BCG vaccination of infants protects young children and infants against the most severe forms of tuberculosis. So TB meningitis, disseminated TB, and protects against TB death. So overall efficacy is in the region of 70 to 75%. The issue with BCG is then not that it doesn't work, it does protect against tuberculosis. The issue is that efficacy wanes over 10 to 15 years after vaccination, so that by the time children are 15 years or older, they are no longer protected. And that means that they are no longer protected against the adult types of cavity-forming tuberculosis that are responsible for infecting other people and driving the epidemic. So that's why we need a different vaccine. BCG is what we call a live attenuated vaccine. So it's alive but does not cause disease in people who have an intact immune system, and it's derived from the strain of tuberculosis that causes tuberculosis in cattle. And the two, to contrast BCG against the two vaccines I mentioned earlier, whereas BCG is live and has many thousands of proteins, the two vaccines I mentioned earlier have just one or two protein components to generate an immune response and are not live. And that has implications particularly for safety, in that live vaccines may, like BCG, have potentially safety implications for people without intact immunity. But it may well be that like BCG is protective, it may well be that one needs all of these antigens and a live vaccine for optimal protection. And hopefully the coming trials will tell us whether we can achieve similar levels of protection with protein subunit vaccines. In the pipeline of vaccines being developed, there are an array of such protein subunit vaccines. There are some live vaccines that I mentioned, including a live attenuated M tuberculosis vaccine, MTBVAC, as well as vaccines prepared from inactivated or killed preparations of whole tuberculosis. So there are a number of candidate vaccines to be tested, and BCG remains let's say the gold standard. For BCG, to answer this second part of your question, for BCG to be replaced by a novel vaccine candidate for vaccination of infants, two criteria would need to be considered. The first is that such a new vaccine would need to be much safer than BCG in terms of primarily its local reactogenicity. So BCG causes a small, but usually small, but an ulceration at the site of injection. So a vaccine that had no risk of local injection site adverse events and distant spread, such a vaccine would be desirable. But even if there was a much safer vaccine, the primary consideration would be, is there a vaccine that offers considerably more protection against childhood tuberculosis than BCG? And there we would be thinking maybe 50% more, again, on top of what BCG already offers. So that's potentially a high bar, but it is not it's not inconceivable, because the protection offered by infant BCG vaccination is not 100%. It's only in the region of 70%, and it's probably less than that for milder forms of tuberculosis. So there is scope for a new vaccine to replace BCG in infancy, and there's certainly scope for new vaccines, whether they are live, inactivated, or protein subunit vaccines, to be given as a boost to BCG that remains given in infancy, or as a vaccine given to adolescents or adults much later in life, to protect against those adult forms of tuberculosis that are driving transmission in our communities.
Thank you, Professor Hatherill. Lastly, could you maybe just comment for us on the intersection between HIV, COVID, and TB?
Yeah. Firstly, I don't know that there is one. So I mean, certainly there's an intersection between HIV and TB, and we know that the HIV epidemic is certainly driving the TB epidemic to a certain extent. In terms of the intersection between COVID and TB, I think what I'd like to draw attention to is that these are very different pathogens. And in fact, I can't think of a pathogen that is more different from tuberculosis than SARS-CoV-2 in terms of the fact that whereas SARS-CoV-2 is rapidly transmitted and rapidly progresses and occurs in epidemic waves, such that provided you throw enough funding at the problem, you can generate new vaccines in as little as 100 days. Contrast a pathogen like that with Mycobacterium tuberculosis, which is slow growing. It causes disease slowly, often to the extent that we don't quite know who is becoming diseased or who is diseased and who is not. Even if a lot more money were thrown out, would greatly like more funding to be available for new tuberculosis vaccine development. But even when those funds become available, we have to wait for these long and relatively slow trials to be completed before we can hope for success. So the bottom line there is we are unlikely to have a new TB vaccine in 100 days, whereas we might have hoped for that for SARS-CoV-2. It might have been reasonable to hope for that for SARS-CoV-2, but it is not reasonable to hope that we will have a new TB vaccine in such a short time.
Thank you for also then touching on the subject of timelines involved for the development of vaccines, as we've seen over the years with tuberculosis vaccines, and then compared to the development of the COVID-19 trials and the vaccines involved in that. Professor Hatherill, you also alluded at the beginning of your interview about the upsurge of TB cases in 2021. Do you think there is a relation, or what does data tell us? Is there a relationship between COVID-19 and that upsurge that we see? What could possibly be contributing to that upsurge?
I think it's a question of whether what we are. So firstly, what we are seeing, is it real, and will it persist in terms of the data over the subsequent 2 or 3 years? But if we are seeing a slight rise in TB incidence globally, as opposed to a continued fall, which was the case before COVID, then it's the question of what is driving that? Is it COVID, or is it the COVID lockdowns or the socioeconomic conditions that came about during the COVID pandemic? And it's factors like, if you just take South Africa, for example, we know that that TB testing was affected, and during lockdown, fewer people were able to be tested. So it's possible that the people who were not tested are now developing tuberculosis, are now presenting for care, and that's why we're seeing increased case numbers. But there's another dynamic, because of course during the COVID lockdowns, people tended to stay at home. They were not mixing as much socially because of the risk of contracting SARS-CoV-2. They were wearing masks and practicing all these infection control behaviors that we would expect to limit the transmission of tuberculosis and other respiratory diseases as well as SARS-CoV-2. So there's a number of different factors at play. I suspect that what we're seeing in terms of this slight rise in TB incidence is we're seeing a phenomenon where TB cases that have previously not been or not presented, not been diagnosed, and not been treated are now coming to the fore. And hopefully this will be a temporary phenomenon. But it just illustrates the fact that we are not going to be able to diagnose and treat ourselves out of the tuberculosis epidemic, certainly not with new diagnostics and new treatments alone. In order to achieve conclusive TB control, we will need a new tuberculosis vaccine strategy in order to prevent people from developing tuberculosis and from transmitting it to others.
Thank you for that. With that, I just want to thank you for your time and for coming out and sharing your insights with us. I'm sure across Africa, all our collaborators and alumni of VACVA will be very interested to hear your viewpoints on vaccine development. And we're looking forward to another session with you sometime in the near future. Thank you.
Thank you, Alana. It's a pleasure.